Alright, boys and girls, welcome back to the drive-thru for a special 2017 edition brought to you by Third Bell. Special shout out to my Third Bell. Let's do great work in 2017 together, okay? I'll only be here with you for half of it. So all we got to do is get off to a good start and then keep the momentum going. And I'm truly trying to do that. I want more energy in my own life. I'm too tired too often, and it's because I make bad decisions. So I'm going to try to change those. Hey, we're just going through like a warm-up, and then we're going to get into your worksheet, okay? We just made up some random function right here, and we said, what is f of 1? Well, to figure out what f of 1 is, we do 1 cubed plus 2 times 1 squared plus 1 minus 4. Well, that's 1 plus 2 plus 1 minus 4. And as we found together, f of 1 is 0, okay? Without using a calculator, hopefully you remember that, maybe you'll remember that since this is a positive here, it's going to start low, bend twice, and end high. And that's all I was asking for you to remember. Okay? Does that ring a bell? All right. So, the factors of the leading coefficient. The leading coefficient here is a 1, so we're going to have to know what that term means. The factors of the leading coefficient and the constant term, this is a constant term, of a polynomial can help you factor a polynomial and solve it. So what are we doing today? We are still just trying to figure out where these things equal 0. Obviously, we've been doing it a lot. It's something that's important. Okay? So let's just get started on this opener, and then I'll give you guys my little soapbox on this particular lesson, which I think is completely unnecessary, yet still worth doing. Okay? It's asking you, is x minus 2 a factor of this equation? Remember, it's a factor of it. There's two ways we can test it. One, well really there's three. We could just divide it out. So let's use this time to actually divide it out, and we're going to use synthetic division because it's easier and because I think we need a review on it. Anyone remember the process of doing, let's see, x cubed plus 3x squared minus 16x plus 12 divided by x minus 2? Remember how to do this with synthetic division? I wouldn't expect you to completely. Excellent. Flip the sign on the 2. Now what do? Write down 1, 3, negative 16, and 12. Give ourselves room and bring down the 1. Do you remember what the process is? Multiply and then add. Excellent. Okay? Multiply. So what am I going to write down here? A 10. Very good. And what's a negative 16 and a positive 10? And what's 2 times negative 6? And what's 12 plus negative 12? So, what's the answer to the question? Is x minus 2 a factor? Yes. How can you find out? Well, one way we can find out is synthetic division. That's what we did. Okay? So x minus 2 is a factor. Okay? So we could rewrite this as x, let me change colors real quick. And let me write this out so you understand what you're doing. X cubed plus 3x squared minus 16x plus 12 is the same thing. I'm not going to write 0. I'm going to rewrite it. It's the same thing as x minus 2 times, well, what did this thing represent? How could you write that as a polynomial? X squared? Excellent. Nice job. As an aside, I'm not just this hippie that lets, well maybe I am, but past that that lets kids do whatever they want. I truly feel like if I give you guys the power to choose how you do things, you have a better chance of remembering it, just like you all did. Okay, so that was excellent. I'm really impressed that a lot of you guys remembered how to do synthetic division and remembered what the heck it was doing. So let's keep going. Does anybody think that they can factor this thing? Paula? Okay, so we're looking for two numbers that multiply to be -6 and add to be +5. And Paula found those to be x minus 1 and x plus 6. So what did we just do? We factored out this entire, let's see, what do they call that? Cubic. All right, so now that we got it to this, okay, then what are the zeros? 2, 1, and -6. And when it asks for the factors, sorry, I wrote through that. Those would be x minus 2 times x minus 1 times x plus 6. Okay? So far, so good. Will you hit the lights for me, Meg? Wow, that was perfect. Hopefully this is showing up on the video. Let's take a little time real quick, and let's pop this thing in our graphing calculator. So y equals x cubed plus 3x squared minus 16x plus 12. Graph it. Okay? Second, trace. We want to find the zeros. It's quick. It's going to be right there. You see it? There's my water bug. I'm going to go down and hit enter. Press up and hit enter. Take a guess. And what does it tell me? -6. Awesome. Right? If I did it again, second trace, I want to find some zeros. Get it over to this side. Here it comes. There it is. Hit enter. Hit enter. Take a guess. There's the 1. And I could do that again. And do you see that's... Remember how to do that? Well, look. We'll get back to that in just a second. But moving forward, that's going to be the best strategy for most of these. Okay? So, next part of your notes is asking you for rational and irrational numbers. So copy these down in your little boxes. A rational number is a number that can be written as a fraction. And when we write things as fractions, they either terminate, so like 1.75, that's a terminating decimal, or they repeat, 6.3 repeating. I don't know if you know this or not, because our number sense isn't the best anymore, but you could also write these as mixed fractions. What's 6.3 repeating as a fraction? 6 and 1/3. What's 1.75 as a mixed fraction? 1 3/4, okay? Now, next question. Numbers that cannot be written as fractions are called irrational. What's the most famous irrational number? Very good. It's pi. It doesn't repeat, and it doesn't end. It keeps going without a pattern. Okay? Here's some more famous irrational numbers. Radical 2. Radical 3. Radical 4? Wrong. Right? What's radical 4? 2. That one's up here. Okay? That's just terms. If you're wondering, because someone in First Bell had a great question, so are these imaginary or these are all real numbers? The only time, so they would all be under the real number category. The only time it's imaginary is if you have a square root of a negative. All right, so that brings us to today's theorem. Here's why, just please hear me out on this little history lesson. So, when in 1995, when I was assigned this question, there was no such thing as graphing calculators. Okay? So, I essentially would have to guess numbers and put them in and see which ones would give me a 0. Does that make sense? So the point of this theorem was to teach me how to guess. The numbers that you guess are something, it's the factors of 18 divided by, there's a 1 there, the factors of 1. Just bear with me. You won't even need to know this, but you should at least know why is this in my textbook in this order. So what are the factors of 18? Well, 1 is always a factor of everything. What's another factor of 18? 2, 3, not 4, 6, 9, and 18, right? And the factors of 1 are just 1. But unfortunately, all of these could be plus or minus. So, the possible rational roots are 1, -1, 2, -2, 3, -3, 6, -6, 9, -9, 18, and -18. I just want you to understand how hard this once was and why this is pointless now, I think. In 1995, I had to test every single one of these and figure out which one of them would give me 0. Do you understand that? What strategy should we use on this to figure out which one gives me 0? Graphing calculator. Every time. This is dumb. Why would we guess and check when we could get it exactly right really quick? Are you following me? So I am required, literally required by law, to teach you these things. Math teachers don't make the laws. And so now I've taught it to you, and now we will no longer probably ever use this as long as we have our graphing calculators with us, okay? So let's find the actual rational roots. Okay? And all we're going to do is, in our graphing calculator, pop that in, y equals, y equals, this is nice because you can kind of just scroll over and change what you need to change. So we want that to be a negative. We want that to be a 4. We want this to be a 15. And we want that to be a plus 18. And let's graph it. Nice. I don't really care about maxes and mins. I'm only looking for zeros, so I'm not going to change my window this time. Okay? So I just go second, trace, 2. Let's see, we got to get over, there it is. Okay, left of it, hit enter. Right of it, hit enter. Take a guess. -3 is one of our answers. Okay, same thing. Second, trace, 2. Enter, enter, enter. 1's an answer. Whoops. Second, trace, 2. Enter, 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 and 6. Okay? So the actual rational roots are -3, 1, and 6. Got it? So I think the video can end now. You guys just do the back of this real quick in your graphing calculators. And tomorrow you'll have more practice on this, and we'll have our little conferences. Can I get a boom? Wow. Boom!